Hey everyone, today we have Jan. He's the CTO of DFINITY. How are you today, Jan?
Very well. Had a long day. It's like evening here already, but happy to hop on and talk to you guys.
Thanks, I appreciate your time. Can you just start off with an introduction and how you got into DFINITY and how your journey has been so far since being CTO?
Yeah, of course, my pleasure. Yeah, the whole journey started about like more than 6 years ago. I mean, I was at IBM Research here in Switzerland before that, and like doing cryptographic protocols for privacy, identity, a bit of distributed systems, distributed protocols as well. And then when this whole crypto, the new crypto space came up, like since the crypto valley in Zug is really like a bit of a jog away from here. That of course raised my interest, and I got a bit into that space more like out of interest. And then at some point, people from DFINITY reached out, and yeah, then I mean, I was also looking around like for other projects that they were doing, but DFINITY was really the only one that, in my view, had like an ambitious mission. It was just not a copy of Ethereum, but really like let's get compute on blockchain. Let's build like this world computer, and so that's why I joined. I really wanted to do that. I knew we could do it because from all the work we have, the guy and colleagues had done at IBM. So to me, that's okay. Sure, let's do it, right?
So can you just give us like a high level overview of ICP versus other blockchains?
Yeah, so I mean, ICP is really like designed bottom up to secure compute, reinvent compute. So the idea is like if you think about, okay, now we want to build a secure computer because like traditional IT systems are not very secure because they're sort of like got like iterated or patched up from like the big old mainframes, if you want, and of course that means you have to do something differently. And I mean, I guess the first idea that you think about if you want to make a computer more fault tolerant, you do start to replicate it, right? And then of course like pure replication is not secure against Byzantine attacks. So you really need to start getting some cryptographic protocols here in the game to make sure that actually now, even if some parties maliciously deviate from their computations, that you can sort of like agree on what the inputs and outputs should be that you should process and what the state is that you should process. So essentially, you have a replicated computer, and then you run cryptographic protocols to make sure that this replication is safe. So that's like quite different from like other blockchain protocols where like Bitcoin started out as like we want to do a replicated ledger. So it's a very simple problem. If you want to do replicated compute, it becomes much harder because now you really need to think much more how how you give program state, how that state gets synchronized if people get out of sync. So it's a much bigger problem, but of course also like a much more fun one to work on.
So there's something called CK bridging with ICP. Can you elaborate like what CK bridging is and how it's different than other forms of bridging?
Yeah, so this like is related to the I guess chain fusion initiative that we are now going presenting very actively. We just had like an event around that at the ECC conference in Brussels. We do the same like in Nashville next week at the Bitcoin conference to explain people how this works. But the idea here is really like as like an internet computer is built up from different subnets. Each subnet is really their own replicated computer. And now, as we sort of touched upon a little before, these subnets run cryptographic protocols, and like one of the protocols they're running is like threshold signing, right? So that means like the subnet that replicated computer, they can jointly sign cryptographic signatures, and so that means they can also sign Bitcoin transactions or Ethereum transactions, and so that's like one part of this like secure bridging, if you want, right? So in order from like one blockchain to interact with the other one, the blockchain needs to be able to sign transactions, but also read transactions securely, right? And so to be able to read transactions securely in a decentralized way, you want the nodes that form your subnet, you want them also to be sort of part of the other blockchain you want to interact with. So for instance, for Bitcoin, we have like every node of like some of the subnets of the inner computer also are like a light client from like of the Bitcoin network. So that means they sort of get the Bitcoin blocks, and from those blocks they then derive the UTXO sets, run that UTXO set through consensus. And so if you're a smart contract on top of ICP, now you know exactly what the latest UTXO set is, whether you've received Bitcoin or not. And then, of course, since as a smart contract, now you can also own, like you have your own Bitcoin public key. Now you can receive those Bitcoin, and you can also spend them by signing the spending transactions and get the internet computer to submit those transactions directly to the Bitcoin network.
So, can you just kind of differentiate like why there's a difference between Bitcoin or Solana versus ICP? Like, what's the key differences between all of them?
Well, I mean, I guess they're very different. There's like many different things that are different, right? Like Bitcoin is really like a protocol that essentially just uses a lot of hashing in order to get some kind of security. So the hashing also like so not only does it include the agreement, it also includes how parties are reimbursed for their work. Like everything is sort of baked into that protocol. But if you want to, get a performant blockchain computer, you actually need to have like a much more modular approach, right? So you want to separate your consensus protocol from the protocol that synchronizes the state, from the protocol that schedules transactions to be executed by smart contracts, from the protocol that manages smart contracts. There's a lot of different tasks that you need to cover. And at the end of the day, for each of those tasks, you need to have like a different protocol, right? And then you have sort of like governance on top, right? And on Bitcoin, essentially everybody can participate in theory. But of course, now only like you can only really participate if you're a very powerful miner. But that's sort of, it's an open participation. But also that means if you have that model, your protocol design looks very different. And on the inner computer, it's something that we call deterministic decentralization, where there's like the governance protocol, governance application that essentially itself is also a smart contract. That smart contract then defines which nodes form a subnet, and that of course now allows you to be much more targeted, because now these nodes can be KYC'd. You know that they run in vetted data centers that are very secure, and that allows you to have like much fewer nodes, right? So if you know these nodes sit in a highly secure data center, you know who the providers of those nodes or the owners of those nodes are, then actually you can, for depending on your security requirements, of course, you can go down to maybe even 13 nodes, right? And so that makes it much more efficient. It makes it much cheaper. If you want to have more security, then you can also have subnets with like 56 nodes and so on. So it's a whole different approach here to the problem of secure a computational infrastructure, secure compute on the internet.
So do each subnets, do they have their own specific language, or is it a universal language between all subnets?
Yeah, I mean it's the Internet Computer Protocol that runs on every node, right? And so every subnet, just like all the nodes, run that same protocol. But then the like subnets then also can talk to other subnets again as part of that protocol, right? So the protocol defines how the nodes themselves exchange messages, how they find consensus on those transactions. But then also it defines there's also like block makers here, and the block makers then also communicate to other nodes from other subnets to figure out whether smart contract in another subnet wants to interact with a smart contract on their own subnet, so enabling communication, right? So in some sense, it's like a replicated version, of the internet itself, right? You have like on the internet, you have like computers that talk to each other. On the internet computer, you have subnets that talk to each other. The subnets are really like a replicated computer.
So one of the features that I've noticed was that the subnets are able to have HTTPS requests, so you're able to host full websites through ICP. Is that correct?
Yeah, that's totally correct. There's like as you know, I was talking about a replicated computer, and you should really think of it as a replicated computer, right? Like any normal computer can be reached via, well, I guess if the HTTP service is enabled, but they can be reached via, HTTPS. They can send HTTP requests themselves, and so that's also the case for smart contracts on the internet computer. They can actually serve front ends directly into users' browser. Every smart contract on ICP has their own URL, like the smart contract ID.ic0.app. That's like the standard URL that every smart contract has. But also you can of course have do some rerouting here. So smart contracts can also have like custom URLs, like oc.app, for instance, is the URL of the OpenChat application, which is like an end-to-end application that only is composed with smart contracts. There's no like cloud services or anything on there. So it's like a full service, actually only composed from smart contracts.
And I've noticed that the images themselves are hosted on ICP, right? Versus NFTs on other projects. They're just metadata pointing to an NFT. Is that correct?
That's totally right.
Yeah.
Yeah, I mean, like a smart contract on ICP can store 400 gigabytes of data, right? I mean, like you would not be able to afford that kind of storage on Ethereum. Well, at least I wouldn't be able to afford that. Maybe if you're some OG, maybe you could. But the point is, yeah, on ICP you can actually store massive amounts of data as part of a smart contract, and that also means, of course, NFTs can be stored like that. And I mean, actually, you can do much more interesting things now, right? I mean, like now NFTs could be, so we have, for instance, like the like a Bitcoin. The name escapes me now. Like so this Ludo is a street artist in Paris, right? And they have this this Bitcoin flower. Exactly, it's called Bitcoin flower. And so here, like the colors of those petals of the flower change depending on the ICP, on the Bitcoin price. So you can actually now have like NFTs that are actually programs, right? And like everything can be an NFT. Any digital artifacts can be an NFT. And like your game sword could be an NFT, and you could use your sword on many different games, because now if the game is also on ICP, the game can interact with that like smart contract that is an NFT. So there's like a ton of nice, exciting possibilities for NFTs if you store them actually on chain.
So what are some projects that you're particularly interested in that have been hosted on ICP?
Yeah, I mean, there's a ton of projects, and of course now I run the risk that I mention some and don't mention like other projects, because I just mentioned OpenChat, which is really like a WhatsApp clone, if you want, or a Reddit like clone that fully runs on the internet computer. And actually, what's also interesting is that application is also a DAO. So it has their own tokens, and as a token holder, you can govern the application. So that means if the developers want to upgrade the application, they will have to submit a proposal to that DAO with the new code to be updated, and then the people who have staked that chat token, they then can adopt or reject that proposal. And if it's adopted, then only then the smart contracts will update themselves. So it's like fully autonomous application, like the whole parts are on chain. So that is very excited. But there actually is like a few more. We call them service network nervous system. So that's like the network, the nervous system that sort of governs that, like your brain kind of thing, right? So there's a ton of this. I forget, about 20 of such DAOs that are dApps on ICP. And there is DEXs that work like that, fully on-chain DEXs. There's like ICP swap, which is like a swap that's also end-to-end DAO. Then there's IC Lighthouse or IC DEX, which is like an order book DEX on the inner computer. There is Helix, who got an award last year from the Crypto Valley conference. There's a recent one which is Omnity, who started to build on the inner computer. It came from another blockchain and now to do like cross like multi-chain application on the inner computer. And I mean, I could go on forever for the rest of the hour, because there's so much like stuff I really am excited about going on in the community.
So since proof of work mining and other forms of consensus algorithms, they're very energy intensive, is ICP's energy footprint a fraction of the scale? How does that compare versus POW mining?
Yeah, so actually we have like the energy consumption on the dashboard of the inner computer. You see exactly how much energy is used. And I mean, as I said before, right? I mean, like some of the subnets only have like 13 nodes. Of course, these nodes are high-grade server machines. They're power efficient by themselves. So the inner computer is like in principle the greenest blockchain out there. And I mean, like at the end of the day, if this really like everything runs as full throttle, then I think it's even greener than the traditional IT stack, because if you think about the traditional cloud provider, you have some replication already there, right? Like you need to have backups, then you need to have like content distribution systems, then you need to have firewalls. So the traditional IT stack also has like a lot of replication, but it's sort of more like patched on replication. Whereas on blockchain protocols such as the internet computer, you actually embrace that replication, right? So because now if you have like a 30-node network and those nodes sit on different parts of the world, actually already distribute the content all over the world, right? And so you don't need to have content distribution systems. And since it's a blockchain, you don't need to have firewalls, right? It's like secure by design. Like Bitcoin could never be hacked. Maybe people's wallets got hacked, right? Or they lost their seed phrase, but Bitcoin itself never got hacked. And so I guess because this is like a different approach to build a secure compute system, actually, at the end of the day, it's much more energy efficient.
So you mentioned earlier about the network nervous system. How does that work exactly? Is it the users that participate in the network nervous system, or is the subnets participate in the network nervous system?
Yeah, so the network nervous system is like the governance application that governs the internet computer. And so, I mean, it's by itself a smart contract or a handful of smart contract. It has like a front end that is served from a smart contract, and it has like a governance application that's a smart contract. But together, what they implement is so people can stake ICP tokens. So everybody who stakes ICP tokens can participate in the governance. So they're part of the network nervous system. And now, when you stake tokens, you get like voting rewards. So if you then participate in governance, that participation is rewarded. And now the governance works like somebody submits proposals. There's like different proposals. There's like motion proposals where people really just like vote on whether or not to accept some free-form text, which like anything can be voted upon there. But then there's also proposals that actually manage the network. So there's proposals to like upgrade the protocol itself, right? I mean, on the internet computer, the protocol is like, if you want to say it's like hard forked like once or twice a week, right? So the new protocol, like I mean, of course, not a radical new protocol, but like new tweaks to the protocol are proposed. So that's also like the code is submitted, or I guess it's typically a reference to some code, and the GitHub reference and so on is submitted as a proposal, and then people can like recompile that code, can verify that code, and then vote whether or not now that new code should be the one that is run by the replicas. And so once the proposal is accepted, then the replicas automatically upgrade that. I guess more technically, it's also like the more proposals get then submitted, because you don't want to like upgrade the whole network at once, right? So there's like follow-up proposals that then say, well, okay, now let's upgrade the first subnet, and then that subnet actually upgrades automatically, and then let's upgrade the second subnet. But then also other proposals are like for smart contracts to upgrade themselves. Also, smart contracts can be governed like that. So, for instance, the network nervous system itself, so it's called NNS for short, is also governed like that. So if that DApp should be upgraded, again, it's a proposal that it gets sent, and then whether or not the proposal gets accepted by all the stakers, then the upgrade is executed automatically.
So what's the difference between a smart contract and a canister?
There's no really difference here. I guess the lingo on the internet computer is canister, because it sort of bundles code and data in one item, and so you can send. I mean, the original vision was that this bundle could be sent around. It's like canned code and data. Because right now it's not so easy to send that bundle around. But actually, what one can do is, so if like one subnet gets too populated, like too many smart contracts run on it, or like storage runs out, because at the end of the day, on one subnet you can have as much storage as like one computer can provide, which is like 40 terabytes. So there's like plenty of storage there. But whenever still that gets used up, actually there's another proposal that can propose to split a subnet, and now suddenly like more nodes are added automatically, and then they split into two subnets that have half of the smart contracts, or those kind of. It's like another very cool feature that the internet computer has, that actually can manage that kind of capacity. But again, to answer your question, like canister is really like just the word for smart contract on the internet computer, because somehow smart contract, I mean, honestly, is a bit of a like very limited term, because it's really just like code and data together that works. So it's much more than a contract, and so that's why I think it's really just a bundle of code and data.
I've spoken to numerous IC developers that said they were originally starting off with AWS or Azure, and they said it was way too difficult, and they actually migrated over to ICP protocol and set their home to work with the IC protocol. So that's got to be quite the compliment to hear a lot of developers say that.
I'm very happy to hear that, and of course I will pass it on to all the developers. We do hear that. I mean, but we also hear sometimes, well, here there's some quirks, here there's some quirks. It's also, I mean, like it's a new world, right? And I guess some people use Rust to implement. So there's some libraries, but then there's other languages. There's less libraries. So there's a lot of stuff you still need to do yourself, right? But if you want to, there's no, like, if you work on I guess on AWS, say, well, I want to have like big database to store all my data. You don't have to worry about it. There's on the internet computer, some of those things are still harder. So I guess it's probably pros and cons here, like everywhere in life. So some things are very easy, and some things are much harder. I mean, you don't need to worry about, I mean, as I said, like firewalls or backups or all of that. I mean, your program never stops. You don't have to worry about like credit cards that expire and your Amazon subscription doesn't get paid and stuff like that. But you have to worry about like like your smart contracts get topped up with cycles. But the nice thing here is like everybody can top up a smart contract with cycles. So if you enter URL and it's not working, just send some like cycles. That's what we call the gas on the internet computers. Just send it some gas and it's up and running again. So because some things are different and you need to get used to. But I take the compliment with pleasure, of course. Thank you.
So are cycles fixed? Or so if a developer tops, so first of all, cycles means that the developers are paying for the gas for the users, right? So do they have a fixed amount that they're paying for each use, or is it fluctuating in price?
No, that's fixed. I mean, there's two important things here, like, and you mentioned like two of them. So yes, I mean, the one of the design criteria was that actually costs have to be, like foreseeable. Costs should be stable. As a developer, you should know, okay, if I now develop an application, a app on the internet computer, you should be able to know what it costs you, right? And so. But on top of that, it should be cheap as well. So like storing 1 gigabyte for a year costs like $5, and that cost doesn't go down. So it's like, while of course you have to you buy ICP tokens and then convert them into cycle. That conversion rate is such that like 1 tera, like 1 trillion cycles is always about like 1 XDR, which is like a mixed bag. Right now, I think it's like $1.44 or something. I'm sure I'm off a bit here, but the point is costs are stable, right? So you know exactly what the operations will cost you in a year from now or in 10 years from now. Maybe it becomes cheaper, but it won't become more expensive. And the other thing that you mentioned is indeed developer pays for that. So that actually allows you as a user just to use smart contracts with your browser only. You don't need to have like any tokens. You don't need to get some wallet. You don't need to get on an exchange to buy those tokens. Don't need to go through some funny on-ramp kind of thing where you need to do KYC. As a user, you just enter enter the URL in your browser and you're good to go, right? The OpenChat application, for instance, I mentioned, you go there, register. You don't even have to have usernames and password, but like we developed something called Internet Identity that manages that secure authentication flow. It also makes sure that you can use the same account across all your devices, and it's really like user friendliness, like the ease of use is like very important to the internet community, very important to myself, so that users can really just like my mother should be able to use the internet computer without having to worry about like anything. Right?
And I'm sure it closes off a lot of security vulnerabilities, right? When I log into an IC site and it just automatically pops up, I don't have to download MetaMask, or there's a ton of fraud MetaMasks and fake applications all over the place. It's just embedded right into the browser.
Yeah, exactly. I mean, I still remember when I was like at East Denver last year, like I was walking around, and I was sort of a bit. I'm not sure what word I should be using here, right? But like maybe sad is the right word here. Like I felt like in the normal computing industry, like where you have like virus scanners, they had like these scanners for all these like MetaMask kind of things, or like like you would run transactions before to see whether they're fraudulent or not. It's like. I mean, I understand how things are, right? But it's sort of a little sad because now you think we have blockchain, right? And blockchain is really unhackable, and so that's like totally like how it should be, right? You should have security covered. I mean, that's the whole promise here, right?
So what's something that you're looking forward to with the ICP protocol, or just industry wide and specific? What's something that's you're looking forward to?
Well, world domination, of course. Well, I'm joking, but like much more adoption of blockchain technology, right? Because I think that's actually the right way to secure the internet, to do compute, and we're literally just taking the first steps. It's still very early, so I think that's very exciting. Like one area that I also find exciting is like the using blockchain with AI. And like AI is a different kind of software, right? It's not logic that is like coded, that you can't look at the source code and understand what it's doing. It's very different. And so because of that, it needs a different approach really to secure it. And I mean, obviously, on the one hand, you want to run it on a blockchain because that's how you secure it, right? If you have like some AI and you tamper with it, it's very hard to figure out whether that AI has been tampered with. Like, you don't see it, right? So sometimes it might be very subtle. It might just mean that when you ask for an insurance, that it won't give you the insurance because it just has been tampered in such a way that you don't get it, or maybe you get a more expensive one, stuff like that. So you want to run that kind of AI on a secure system. And like a lot of people talk about decentralized AI, but they mean something very different, right? They don't mean that now actually AI runs on a decentralized system. They mean that like blockchains just sort of orchestrates that, and really people just rent out their GPUs to people, and that's like why they mean decentralized. But to me, decentralization, the whole point of decentralization is actually to make systems secure, right? So to remove single points of failure. That also means for AI, if you talk about decentralized AI, it also has to mean, like no single points of failure. So that means like AI itself has to be, like replicated to be secure. It has to be tamper-proof. You want it to be verifiable, so that you get the same results as I get. I want to make sure that all the data that was input to the AI is actually also secure, right? I mean, if my kids use AI, I want to make sure that it doesn't show them some porn images that somebody smuggled into the input data, stuff like that, right? There's a lot of open questions here. And a lot of attacks actually have been demonstrated against the AI, right? So if you sort of know how the model works, you can actually do queries in a way that the AI gives like unintended answers. So there's a lot of security questions around AI, and I mean, honestly, blockchain is the only answer here. And I mean, I guess what gets me excited is that also, like at DFINITY, we're really working towards that. So we have actually demonstrated that AI can run on chain. So we have like image recognition already demonstrated. We have like face recognition already demonstrated. And already these examples show that actually you can do KYC on blockchain. Right now you can have like a DeFi with KYC, with AI on blockchain. But I think the larger point is really you need to bring AI on blockchain. And so the plan here is that we would have subnets that have GPUs, but the server have GPUs, and then actually run also AI in a replicated fashion to make it secure. So I mean, I guess at the end of the day, I'm sort of proud that at DFINITY we really want to solve, address the world's biggest problem, like cyber security, AI, making AI secure, and so on. And I mean that what gets me out of the bed in the morning to go and work with like a bunch of very smart people on these very hard problems.
Well, I mean, just the Actors Guild, right? They're trying to sue OpenAI, and if you had a blockchain connecting all the inputs to the outputs, you could, make sure that everybody got royalties from it. So I think
Yeah, exactly. I mean, I think that's a huge benefit, right? You put like data marketplace on a blockchain, right? And then like all the IoT devices out there, that sensors that measure weather data and all of that. I mean, it's like countless, right? I mean, we talked about energy efficiency before. It's like energy metering. wind parks, so much data out there, right? And if you put all of that on blockchain, you can really make sure that you have a marketplace for that. You can make sure that the AI just can use that data if they paid for it. Like with normal data, I mean, the data is like being digital, right? Everybody can copy it. It's hard to, and then if the AI the data was used to train AI, how do you prove that somebody did that, right? Very difficult to prove. So yeah, that's another good example, great example where blockchain can really be helpful in the AI space.
Yeah, deep fakes too, and all the political rhetoric and everything like that. So before, I want to be courteous of your time. So is there anything that we didn't get to that you would like to chat about?
Well, I think, yeah, I guess the two things that really get me excited now is AI is one, and this, like we touched about it as well. Chain fusion is the other one, right? Like there's a ton of blockchains out there. Each one of them is pros and cons. Right? Like Bitcoin is the store of value kind of thing, and I mean. And like I get excited if like people use Ethernet computer with the Bitcoin network. And so, for instance, there's like Bionic, who builds like a ordinals marketplace on the internet computer, and sort of like like this combination of different properties, right? Like a very efficient protocol. There is this store of value, and and I guess maybe nobody had thought about that, or like Satoshi at the time might not have thought about, okay, the like energy company use like Bitcoin mining to store their like to transform their like energy that they have produced like to in abundance, cannot sell otherwise, so they mine it on Bitcoin and then have Bitcoin as a store of value. There's a ton of application here that people haven't thought about it yet. And with chain fusion, actually you can make use of different blockchains, different properties. So I think that I find very excited. I mean, we talked a bit how it works, but like like I'm really looking forward to like what kind of other applications people come up with in that space.
Yeah, I'm a huge fan of Bob. So like, where can we find you? How can we get in touch with you if we have any further questions with anything?
Honestly, the best is probably on Twitter. Go to my Twitter feed, and my DMs are open. So it's actually better, ironically, than email. Email is so much going on, and Twitter, I guess people are a little shy still, so I don't get too much there. But that makes sure that actually people can reach me. Actually, maybe another example. This is like something we're working on, like oec.com is like another smart contract. It's actually a multi-chain wallet. It shows that this chain fusion example as well. So you can have like like a browser only, like a wallet-less wallet, which is sort of mind-boggling, right? And you can have your Bitcoin in there, you can have your Ethereum in there, like other chains, and you don't need to remember any seed phrases or anything like that, right? You just fire up your browser, use your passkey authenticator on your phone, and you're good to go. It's secure. It's like network custodied, right? Like there's no custody provider really. It's all just a blockchain. And stuff like that, I think I find it very exciting as a cryptographer, but also like as an end user who can just really like use their devices in one way. You don't have to think about it, right? And if you download some other crypto wallet, the first thing it forces you is to remember a seed phrase, and then you have already lost, right? That seed phrase. What do you do now? Like write it up, take a screenshot, or put it somewhere else, right? And then of course, you just want to test the wallet, but then you started liking it. But now you're sort of already have like an insecure system. It's like in crypto, a lot of like a lot of people are nerds. Maybe they can deal with that, but actually, it's not. It's very hard for users, even for all the nerds. And because we really, as an industry, have to work towards making this usable for an end user. People shouldn't even feel that they're talking with a blockchain protocol, right? They're using blockchain. And for the internet communities, it's a bit of a blessing and a curse, because a lot of people, when they see the properties, they wouldn't even believe that this is a blockchain, right? Because it feels really like Web 2. But I mean, that's the goal. It has to be like Web 2. It has to be much better than Web 2, like much more secure, much more usable. And I think that's really important here.
Yeah, I agree. Is that using the root of trust when you sign in through your cell phone? Is that just using your device secret key? Is that how that works?
Yeah, that's exactly how it works. That it uses the passkeys protocols, like, which is like the FIDO standard, like the like for the online secure online authentication. But indeed, it uses this like security chip in your phone that gets unlocked with a biometric, and then it uses the WebAuthn like standard for secure authentication, and that's how like authentication towards the internet computer are secured. And so that means like now as a smart contract on the internet computer actually with internet identities sort of store that public key, and then so you do cryptographic authentication, the most secure authentication that exists, right? And then sort of your browsers are hardened for all of that. And so like the OSI wallet, right? Then you use the threshold crypto to manage your Bitcoin, to network custody your Bitcoin. And that also makes it, you can actually have a backup device, right? You can have like another YubiKey that also has passkey support. You also like use that as a alternative login mechanism. You can use the second phone. So now suddenly you can use actually many devices to log into your like smart contract wallet, and that wallet then manages your public. So that's like like how you should actually do manage cryptographic keys, right? I mean, if the key is managed by a seed phrase that you have to use somewhere, then you have to have hot wallet, cold wallets, hotkeys. I mean, like this whole nightmare that the crypto industry bestowed upon people, right? And really have to get better here at using technology and using security technology.
And it also opens a whole host of different security risks, right? If I download the wrong MetaMask and type in my wrong private key, then it's over for me. So
yeah, totally.
well, I appreciate you coming on, Jan. It was a pleasure, like always, and thanks for the update.
Thanks a lot, Darren. Always like happy to do this again at some point.
Sure. Bye.
Bye bye.